So what we need to do to select that table, the employee demographics table, is we need to select everything. That's what this star means. The star means everything, all tables, all rows. Now we do have a limit on here. We have a limit to 1,000 rows. So if we had a table that had 50,000 rows, this limiter would be an issue. It would still limit it to 1,000 rows. We would have to change that to 2,000, 5,000, probably all the way up to 50,000 if we wanted to view everything. If we had, say, 1,000,000 rows, we would need to come up here and say don't limit, and it would give us 1,000,000 rows. The reason they do this is mostly to keep the processing time low. If you have 1,000,000 rows, it's going to take a long time for the output to actually appear. So let's come right back here. The next thing that we need to do is we need to say select everything, and now we need to say where we're selecting it from. So we're going to come right down here and we're going to say from, and now we need to specify what table. And we're going to say employee underscore demographics. And at the end, we need a semicolon. Now, why do we need a semicolon? This is going to tell MySQL that this is the end of this query. So if we write another one down here, which we will in just a second, it'll be able to distinguish between the two queries. We're going to go ahead and we're going to run this, and we'll just use this execute right here instead of this one. And there we have our entire table. So we were able to get our table. Now, there is one thing that is potentially wrong depending on what you're using it for. But what we didn't do is we did not specify the actual database before it. We only specified the table. And this works perfectly fine because if you look over here on this left-hand side, we have Parks and Recreation. It's in black. It's bold. That means that we're hitting off of this database. What's going to happen though if we come down here to the sys database and we double click on it? Now this database is highlighted. So now when we're selecting this table, we're trying to select this table from the sys database. Let's go ahead and try this. If you notice, we have no output. Let's come right down here and pull this up. It's going to say employee sys dot employee underscore demographics doesn't exist. So it's assuming that we're highlighting this sys database. That means we're trying to pull from that database. Now we can still have this highlighted and still select the correct database by saying parks underscore and underscore recreation. And let me spell that right, dot. So now we're selecting everything from Parks and Recreation dot employee demographics. If we run this, we do get the correct output. That's just something to consider, especially when you're working with a lot of databases and a lot of tables. It's usually best practice to actually put the database in front of the table name. Although throughout this lesson, we probably won't be doing that every time since we're only going to be using this Parks and Recreation database. Let's go ahead and double click this. So we have this highlighted again. And let's click all of this. Let's copy all of this. We're going to come down just a little bit right here. Now, so far we've only selected everything, but we don't have to do that. We can actually just select one column if we would like to. For example, if we got rid of that star, we say first underscore name. We're selecting the first name column from this table. If we highlight this query and we hit the execute button with the I, now we are only going to return in our output all of the first names. And we can add a lot more. Let's actually look at all of these. We can separate multiple columns with a comma. So we can do first name, comma, last underscore name, and then we could do birth underscore date. So now we have 3 separate columns. Let's go ahead and run this. And now we have first name, last name, and birth date in our output. Now the way we just wrote it is all on one line. And that's perfectly acceptable because MySQL is going to read it the exact same as if we did it in a different format, as long as it's still in this order. But sometimes you'll see it like this, where it's select first name, comma, last name, comma, birth date, all on different rows. Now there's a lot of different use cases for this or reasons for this, but it typically can be easier to read. Also, if you're doing any type of functions or calculations in the select statement, it's easier to separate those out on its individual row. Now again, we won't always be doing this, but it does help. Sometimes if you're doing that, it just makes it easier to visualize. For example, if we added the age, so let's add age in here. Let's run this. Let's say we were doing a calculation where we wanted to add, 10 years to their age. So we'll say age, and we'll actually create a new row for this, or new column. We'll do age plus 10. So now we can easily see that we're doing plus 10 here. And this is another thing that you can do in the select statement, things like calculations. So if we go up here and we run this, we'll now have an age column, but we'll also have an age plus 10 column where it just adds 10 to the age. And we can at least visualize and really easily see this when we're doing these calculations. Now, something really important to know about any type of calculations, any math within MySQL, is that it follows the rules of PEMDAS. Now, PEMDAS is written like this. It's PEMDES. Now, what I just did right here with this pound or this hashtag is actually create a comment. So this code isn't going to actually run, but it's just for note-taking or seeing things in your actual editor window. I'll come back to comments in just a second, but just wanted to explain what that was. Now, what PEMDAS is the order of operations for arithmetic or math within MySQL. This stands for parentheses, exponent, multiplication, division, addition, and subtraction. So this is the order that these calculations are going to run in the execution engine that MySQL has. So if I do age plus 10, we'll put that all in parentheses, and then we come over here and we add times 10. So we're doing plus 10 here and then a times 10 here. What's going to actually happen is it's going to say age plus 10. So 44 plus 10 equals 54. Then we're multiplying times 10. The parentheses executes first because it comes first in this order, parentheses. Multiplication comes next because it's this one. And then anything else after that, if we did, plus 10, you could run this. And you'll notice that it still follows the logic. 10 was just added at the very end to all of these outputs. Now let's go right back up here. Let's select everything again from this table. Let's pull up this table so we can see it a little better. And let's go down, because the last thing that I want to show you is something called distinct. Now, this is really, really useful, and you use this a lot in MySQL. What distinct is going to do is it's going to select only the unique values within a column. Let's go ahead and copy this employee demographics, bring it right down here. Let's say select, and let's do first underscore name. So now we're just selecting the first name. Let's come right down here. There we go. So now we're selecting just the first name from this column. Now these are all unique values. So if we come right here and we say distinct, nothing should happen to this table because these are all unique values. Let's go ahead and run this. As you can see, the output looks exactly the same. But what if we were to do something like gender? So let's come here. Let's do gender. Let's run this. It keeps going down. I don't know why it's doing that. But now we have male and female. Now these are not all unique. We have female, 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 and female, and the rest are males. So there's only two unique values here. So if we come right here and we say distinct gender, now there should only be two in the output, male and female. Let's go ahead and run this. Male and female in our output. Now this works perfectly in one column, but what happens if we have two columns? So let's do first underscore name, comma, gender. Let's go ahead and run this. Now the combination of first name and gender are no longer unique. Now Leslie and female are being grouped together, and it's taking the distinct between both of these columns. So when we're only working with gender, it's only looking at this one column for both male and female. So it reduces it down to the only two unique values. But because we add the first name, all of these values are unique. So therefore, the name plus the gender combination is always going to be unique. The very last thing that I want to show you in this lesson doesn't actually pertain to the select statement, but I want to save this code. Let's say we wanted to update this or upload this into our GitHub or save this and send it to somebody. We can do that. We can save it by clicking this save button right here. I'm going to go ahead and click this. And now we're in our MySQL Beginner Series folder. I'm just going to save this, and I can save this as anything I want. So I'm going to say 2.select statement tutorial. So now when I save this, you'll notice that the name gets changed up here to 2.select statement tutorial. Let's exit out of this. I'm going to open up, and now I'm going to come here to the select statement tutorial. I'm going to open it. And now I have our code again, exactly as we had it written before. Hello everybody, in this lesson, we're going to be taking a look at the where clause. The where clause is used to help filter our records or our rows of data, whereas the select statement is used to help filter or select our actual columns. So when we're using the where clause, we're only going to return the rows that fulfill a specific condition. Let's take a look at exactly how this works. Let's say we come right up here. We're going to say where, and let's go down with that one. Let's say where, and now we need to specify what column we're about to create this condition for. So we're going to say first underscore name. So we're saying where the first name we'll say is equal to, and let's do quotes and let's say Leslie. So we're saying the first name has to be equal to this value right here, which is Leslie for Leslie Nope. If we run this, there's only going to be one row that's returned because Leslie is the only Leslie in this entire table. Now we just used an equal sign, and that's actually called a comparison operator. And there's a few other comparison operators that you can use. Let's take a look at some of these other ones. Let's pull this down right down here. And let's actually highlight the select from, and we're going to run it with this one right here. It's going to only select everything from the whole table. So we didn't select that where clause. Let's go right down here and let's look at this salary field. So I'm going to say where the salary, and I'm going to do a different comparison operator called greater than. So when the salary is greater than 50,000. Now, one thing I want to note before we actually run this is that right down here, we have Tom Haverford, who makes exactly 50,000. And I think there's one more, Jerry Gergich, which also makes exactly 50,000. If we run this, you'll notice that both Tom and Jerry are not in this output. But in the salary field, everything is greater than 50,000. The reason for that is that Tom and Jerry made exactly 50,000. What we're saying right here is where the salary is only greater than. If we want to include Tom and Jerry, we have to say greater than or equal to. And now we'll select 50,000 or above, whereas right here, or before when we were doing just this, it was greater than 50. It didn't include the 50,000. Let's go ahead and include it and run this. And now you'll notice that Tom and Jerry were both included because they had exactly 50,000 and we said greater than or equal to. Now we could do the exact same thing, but with less than. So we have less than 50,000. And now we only have two people who make less than 50,000. That's April and Andy. And if we say less than or equal to, and we run that, now we include both Tom and Jerry who make exactly 50,000. So it's less than or equal to $50,000. Now what we're going to do is head on over to a different table. We're going to do the demographics table. Make sure I spell that right. And let's add our semicolon. Let's run this. And what we want to look at is the gender really quick. So we're going to say where the gender is equal to, we'll do in quotes, female. And if we run this, we get all the genders that are equal to female, but we do have something called the not equal to, and it looks like this. It's an exclamation point and an equal sign. This is going to say where the gender is not equal to female. So if we run this, you'll notice that the gender is all male now. Now, so far, we've worked with things like integers, which are numbers. We've worked with characters or strings, like names. But there's a different type of data type as well in here. We have a date column for these birth dates. Now, in the where clause, we can also filter on birth dates. Let's come over here, and we'll say birth underscore date. Let's say it's greater than, and within quotes, we'll say 1985-01-01. This is kind of the standard default date format within MySQL, which is year, month, and day. If we go ahead and run this, we can also take all the people who are greater than or were born greater than 1985. So all of these dates are greater than 1985. Now, the next thing that I want to take a look at is logical operators in the where clause. So logical operators are things like and, or, and not. Now, these are called, and let's add this, logical operators. So logical operators allow us to have different logic. And let's take a look at how this works exactly. Let's copy this down because we already have this one written out. We're saying where the birth date is greater than 1985. We can also say where the gender is equal to male. So we can say, and the gender is equal and then we'll say male. So we're adding a different complexity or an additional conditional statement within our where clause. Let's go ahead and run this. So now we're only selecting birth dates that are greater than 1985 and where the gender is equal to male. Only the rows that fulfill both of those are returned. Now the and says both this and this have to be true, but we could change this. We could say or. What this means is either this one has to be true or this one has to be true in order for it to be returned. So let's go ahead and run this. You'll notice that Jerry Gergich was born much before 1985, but since he has a male gender, he is in our output. And we could also use the not operator by saying or not gender equal to male. So now what this is saying is the birth date could be greater than 1985, or it could not be equal to male, which is female. So if we look at Leslie Knope, she was born before 1985, but because she is female, she is in the output. Now, like we talked about in the last lesson, there is something called PEMDAS, and that actually applies to these logical operators as well. So if we run this entire table, let's go ahead and run this. If we're looking at this entire table, let's say we want to get someone very, very specific. Let's say we're going to do where the first underscore name is equal to Leslie and their age has to be equal to 44. That's extremely specific. And we can actually just do it like this. We don't need quotes for integers. We could just do the number if we'd like to. This is very specific. This is only one person. But if we put this in parentheses, we can add an or over here. We could say, or the age is greater than, let's just do 55. Let's go ahead and run this and then we'll take a look at it. So within these parentheses, we have an and operator. What that means is both this condition has to be met and this condition has to be met. And that's only one person, that's Leslie Knope. But then outside of these parentheses, we have another conditional statement, or the age is greater than 55. So what we're saying within these parentheses is that this is an isolated conditional statement. Within these parentheses, if this is true, then in our output, it'll be returned. But then we have an or condition, which says, or someone with the age of greater than 55 can also be in the output. So these parentheses can be really helpful when you're actually using it in the where clause with these and, ors, and nots. Now I want to take a look at just one more thing. And let's bring this down here. And let's get rid of this entire thing. Now, the last thing that we're going to take a look at is a like statement. Now, the like statement is super unique because we can look for specific patterns. We're not necessarily looking for an exact match. Like here, if we said where first underscore name is equal to Jerry. If we're looking for Jerry, it has to be exactly Jerry. But if we take this out, say JER, and then we run it, we get no output. It has to be an exact match. But here's where the like statement comes in, because we can actually say like JER, and we can add two special sequences or special characters within our like statement. So those special characters are the % and the underscore. The % means anything, and the underscore means a specific value. Let's see how that actually works. So what we're going to do is we're going to say like JER %. That's the first one in this like statement. What this says is the first name is like, starting with JER, but then has anything after it. Doesn't matter what it is, as long as it has JER at the very beginning, it will be returned. Let's go ahead and run this. Now the only person who starts with JER is Jerry. But what if I took the J out of here? Now it's saying it starts with ER, and that's not anybody. What we can do is we can add another % at the beginning. This is going to say anything comes before, anything comes after. All we're looking for is ER somewhere in their name. Let's go ahead and run this. There still is only one person, and that's Jerry. Now let's come up here and let's get rid of this. And let's say we're looking for everyone's name who starts with A. We can do that really easily by saying A %. All that says is it starts with A. We don't have a % before it, which would say this string just has to have an A somewhere in it. If we have it like this, this means an A has to come at the beginning. Let's go ahead and run this. In our output, we have April, Anne, and Andy. Now let's take a look at the underscore. If we get rid of this percent sign and we do 2 underscores, 1, 2, this is going to say it starts with an A and then it has 2 characters after it. No more, no less. So if we run this, Anne is going to be the only person who's returned because she has an A and then 2 characters after it. Now, if we want Andy, we can specify that by doing another underscore. That's 1, 2, 3. And now Andy is the only one in our output. Now there was also April in there, but she had more than 3 characters. But we can actually get her in our output by doing a percent sign. So we can combine both the underscore and the percent sign. And this is going to say it starts with an A, has 1, 2, 3 characters, and then it can have anything after that. So it just has to have at least an A and have 1, 2, 3 characters after it. So let's run it. Now you can see April comes into here because she does have A. The P, R, and I are the 3 next characters, but then we have a percent sign that allows that L to be in the output as well. Now we don't just have to do this with strings or text like April and Andy. We could also do this with birth dates. For example, Andy's birth date is 1989. We could say where the birth underscore date is like, let's say we want to look at everyone who is 1989 or born in 1989. Let's go ahead and run this. And Andy's the only person born in 1989, but again, we looked at the year at the very beginning. So that is how the like statement works. It looks for a specific sequence within that column that you can search for. So it doesn't have to be an exact match. As long as it has that specified sequence that you've put in there, anywhere within that cell or that column. So hello everybody, in this lesson, we're going to be taking a look at group by and order by in MySQL. Now, when you use the group by clause in MySQL, it's going to group together rows that have the same values in the specified column or columns that you're actually grouping on. Once you group those rows together, you can run something called an aggregate function on those rows. Let's see how this actually works. Let's go ahead and copy this right here. We'll bring that down. And let me go back up one. Let's go ahead and write gender right here. Now we want to group on this gender column, and we're going to say group by gender. Let's go ahead and run this. We'll see what we get. And so we have male and female. Now we could get the exact same output by saying select distinct gender from this table. What is group by doing that the gender actually isn't doing? Well, it's actually rolling up all of these values into these rows. So later when we run aggregate functions like average, min, max, we'll do it based off of these rows, and all those rows are rolled up into these 2 rows, and we'll see that in a little bit. Now, what if I was to come up here and in this demographics, we have a first underscore name. What would happen if I'm selecting the first name, but I'm grouping by the gender? Let's go ahead and run this. If we come right down here, we pull this up, you can see that the select list is not in group by clause and contains non-aggregated columns. What this means is that when you are selecting a column, if it's not an aggregated column, like say average of something, if we're not using the aggregate functions in the select statement, it has to be in the group by. These have to match. So this gender has to match this group by if we're not performing an aggregate function on it. Let's go ahead and run this. And now it works properly. Now let's go back up. Let's run this query because I want to select everything again. But let's say we wanted to take a look at the average ages for gender. So what we're going to do is we're selecting gender. We're also grouping by gender. But what we're going to do is add a comma, and we'll say the average, that's AVG, that stands for average. And then we're going to put in here age. So now this right here is an aggregate function. This does not need to go in the group by. We're just grouping on the gender, and then we're performing this aggregate function or kind of a calculation based off of those grouped rows for gender. So let's go ahead and run this and take a look at the output. So what this is telling me is that for the males, all of the male rows that were grouped, the average age is 41 point, let's say 3. And for female, the average age is 38.5. So super quickly, you can tell that the average age of females is lower than the average age of males. Now we'll take a look at aggregate functions more in just a little bit. Let's actually go to a different table. Let's come right down here. We're going to go to the salary table and just select everything for now. Let's go ahead and run this. Now, what we're going to actually be grouping on is this occupation right here. Now, there's a lot of unique values. It's not as distinct as the gender, which only had 2 values. You'll notice we do have a few that are the same. We have ones like office manager. So when we come up here, we're going to say occupation. And of course, we need to group by the occupation as well. Now let's run this. You'll notice that office manager only has 1 row. Let's say we also want to group on the salary. Let's say salary. Now we can group on multiple. So we're going to say salary like this. So we're grouping on the occupation as well as the salary. Now let's run this. You'll notice that we have 2 rows for office manager now. This is because this salary and this salary for those 2 employees are different. We have 50,000 and 60,000. For this, I just wanted to demonstrate that if these had both been 50,000, there would only be 1 row. Office manager, 50,000. But because this is a unique value, different than 50,000, they have their own individual rows, which we would then perform our aggregate calculations on. Let's go ahead and get rid of that because we will not be using that anymore. I just wanted to demonstrate it really quickly.
Because you can get digital.
So before we were looking at gender and average age, and we were also grouping on the gender. We can perform other aggregate functions as well. Let's take a look at some of those. We could look at the max age as well. The max is going to show us the highest value within each of those groupings. So we have a male and female. The max age for those, for the male, is 61, and the highest age for the female is 46. We can do the exact same thing, except we can say min, or the exact opposite thing. We can say the minimum age. So this is going to be the lowest for both the male and the female. Go ahead and run this. Now we have female and male, and the minimum age is 29 and 34. And there is one last one that I want to show you, which is count. We're going to do count. Now count is going to count the actual rows within this age column. So if we run this, you'll see that we have 4 females for count, and we have 7 males. It's just telling us a count of how many values is in this column when we're actually grouping on the gender. So that's how we can use group by to actually roll up and group all of these similar values within a column or columns and perform our aggregate functions on them. Now let's come down here, and what we're going to take a look at is order by. So I'm going to say order by. Now let's actually pull in this demographics table right here. We're just going to say select everything and run this really quickly after we add a semicolon. So order by. Order by is going to actually sort the result set in either ascending or descending order. Let's take a look at how this works. At the very end, we could say order by, and we could order by the first underscore name. So we're going to take this column, we're going to order all of our rows based off of this one column. Let's go ahead and run this. So it's going to do it based off ascending order, which means smallest to largest. Now this is a text column or a character column, so we do it A to Z. So Andy and April all the way down to Tom. Now by default, this is in ASC order, ascending order. And if we run this, it's going to be the exact same output. But we can change this to do it the opposite, highest to lowest, or Z to A, by doing descending. So now if we run this, you'll see that it goes Tom all the way down to Andy. Now let's take a look at ordering on something like gender and age, because we can do both at the same time. So let's order by the gender first. Let's go ahead and run this. And you'll see that all the females are grouped together, and then all the males are grouped together because that's just the order in which it is. But we can do an additional column. We can also do it based off of the age. Let's go ahead and run this. So now within the female, since that came first in our order by, we're ordering by the gender, and then we're also ordering by the age after we've ordered by the gender. So now it's 29 all the way up to 46, and then 34 for males all the way up to 61. Now we can change this just for the age. Let's say we want to do age descending. So gender will stay the same in ascending order, but now age will be in descending order. Let's go ahead and run this. Now female and male stayed the same, but now it starts at the highest down to the lowest. Now this is something that I would absolutely do in real life, except sometimes you can make mistakes and sometimes you do the wrong column first. Let's do age and then we'll do gender. Now, if we run this, the gender is not going to be used at all. And this is because there are no unique values that are going to be on the same row. So notice all of these values are completely unique. So the gender never is actually used to order anything on, because if there were things like 34, 34, 34, 34, these would be ordered based off of the gender. But since there's no unique fields, this is really pretty useless. That's why the order of the order by, or the columns that you place in the order by, are actually quite important. Now, the last thing that I want to show you, and I'll just go back to gender and age, is that you don't actually have to use the column names. We can use the column positions. Now, I will preface this by saying I don't recommend doing this, but I sometimes do it in shorthand for just a quick query if I know the column position and I don't want to write out the whole name. Sometimes I do it, although it's not best practice. But let's take a look at it. So gender is the 1, 2, 3, 4, 5th column. I'm going to replace this with 5, and age is the 1, 2, 3, 4 column. So these are the positions of the fields, but not the names of them. If we run it, we're going to get the exact same output because these represent these columns appropriately. But again, I just don't recommend it. It's kind of a slippery slope that I've fallen down myself many times. And when you get to more advanced SQL and you're creating things like stored procedures and triggers and all these things, this can actually cause a lot of issues. If you were to add any columns or remove any columns, then you'd be ordering by the wrong column because let's say this last name got removed, we didn't want it for some reason, then the gender is 1, 2, 3, 4. Now we're ordering on the wrong column, and that would be a big mistake. So just by best practice, it is better to do gender, age, but I just wanted to show you that in case you want to be like me and kind of go down the wrong path. Hello, everybody. In this lesson, we're going to take a look at the difference between having and where. Now, in the last lesson, we looked at group by and order by. The most obvious thing to do would be to come right here and say where, and we're going to say this column, which is actually named this, we'll say where the average age, let's say is greater than 40, which would only be the males. So let's go ahead and run this. And as you can see, we're not getting any output. Let's bring this up and take a look at the error. It says invalid use of the group by function. What's actually happening is something to do with this group by gender right here. When we're selecting gender and then we're performing an aggregate function, this occurs only after the group by actually groups those rows together. So when we're trying to filter based off of this column right here of average age, it really hasn't been created yet because this group by hasn't happened. That's where the having clause comes into play. So let's go ahead, and what we're going to do is we're going to get rid of this. We're going to come right down here, and instead of where, we're going to say having. Now, having was specifically created for this exact example. It comes right after group by, and after group by, we can filter based off of these aggregate functions. So now if we run this, we're going to get an output that only has where the average age is greater than 40. Now let's take a look at just one more example, and I'm going to show you how you can use both in one query. So instead of demographics, let's look at the salary table, and let's run it. Now, in this salary table, we have this occupation, and remember, we have this office manager that happens twice. And this is going to be our main example. So we're going to say occupation, and then we'll say the average salary. Now we'll need to come down here, and we'll say group by. Now we're going to say occupation. So this should look pretty similar because right here we have our office manager, and one of the office managers made 50. One of the office managers made 60, so the average is 55,000. Now, I can use the where by saying where, then I'll say occupation like, and let's see people who are managers. So I'll say percent manager percent and close that quote. So they're like a manager. And then I want to see where a manager makes more than, let's say, 75,000. So I won't actually say where. I'm going to say having an average salary, and I need to add a space there, having an average salary greater than, let's say, 75,000. And let's run this. So now I filtered at the row level right here in the where clause, but then down here, I filtered at the aggregate function level. This having is only going to work for aggregated functions after the group by actually runs. So that is the difference between the having clause and the where clause. The where clause you're most likely going to use a lot more, but if you do want to filter on those aggregated function columns, you have to use the having clause. Hello everybody, in this lesson, we're going to be taking a look at limit and aliasing. Limit is just going to specify how many rows you want in your output. If we take this table, for example, if we come right here and we say limit, let's do 3. If we run this, it's only going to take the top 3 that we have. Let's go ahead and run this. As you can see, we have employee 1, 3, and 4, Leslie, Tom, and April. Now this seems super straightforward, really easy, but it can be combined with order by to actually be really powerful. For example, let's say we wanted to take the 3 oldest employees. All we'd have to do is come right under here, and we say order by, and we'll order by the age in descending order. So we're going to order on age descending, and then it's going to take the top 3. So if we run this, and very quickly, we have the top 3 oldest people in this table. Now there is one additional parameter that we can use in limit, and all we have to do to access it is have a comma here. Now what this is going to do, and I'll put a 1 here. What this is going to do is it's now going to say, we're going to start at position 3, and then we're going to go 1 row after it. Now I actually want to take one of these people. So let's start at position 2 and select the next one after it, which should be Leslie Knope. So we're going to start at position 2, and we're going to select the 1 right after it. So we're going to start at position 2, and then 1 means we're taking the next 1 row. Let's go ahead and run this. And as you can see, we got Leslie Knope in our output. Now let's come right down here. We are going to now look at aliasing. Now aliasing is just a way to change the name of the column for the most part. And it can also be used in joins, but we're going to take a look at joins or aliasing joins in the intermediate series. In a previous lesson, we looked at a group by that looked like this. We selected gender, then we said from, I believe it was employee underscore demographics. Then we said group by gender, and we also had the average, and I think it was age. There we go. And we'll add our semicolon. Let's go ahead and run this. In our output, we have gender as our gender column, the same as the column name, but then average age is average age. And so if we want to actually do something like a having, where we say having the average age, let's say greater than 40, like we had it, we have to actually use this aggregate function in our having clause. And we don't want to always have to do that. We can actually change the name of this column and subsequently use it throughout our query with that aliased name. So I'm going to say as, and that's the keyword to actually change it. We'll say as, and we'll do average underscore age. So now we've changed this name to average underscore age, and we can come down here to having and say having the average age greater than 40. And when we run this, it works perfectly. And you'll notice that the name of the column was actually changed. Now, this as isn't actually 100% needed. It's kind of implied. Even if we get rid of it, it's implied there's like this as in there somewhere. But we don't have to have it. If we took it out and ran it like this, it would still work exactly the same. Hello, everybody. In this lesson, we're going to be taking a look at joins. Joins allow you to combine 2 tables or more together if they have a common column. That doesn't mean the column name has to be the exact same, but at least the data within it are similar that you can use. There are several joins that we're going to look at today, like inner joins, outer joins, and self joins. These are the 2 tables that we'll be working with the most throughout this lesson. we have the employee demographics table as well as the employee salary table. Now within the employee demographics table, we do have this employee ID column. And if we look at the employee salary, we also have the employee ID column. So in this instance, the column name is actually the exact same. And of course, the data inside of it is also very similar. So let's start by writing out an inner join. This is probably one of the most common joins, one of the most simple joins as well. An inner join is going to return rows that are the same in both columns from both tables. So let's see how we can actually write out this join. Let's come right down here and let's copy this. This will be the first table that we start with, and then we'll join this salary table onto this demographics table. So what we need to do is we need to come right here and we need to say join. Now by default, join represents an inner join, although we can write inner join here to make it more explicit, explicitly writing out inner join. Then we're going to come up here and we're going to say employee salary. So we're selecting everything from the employee demographics and we're doing an inner join on the employee salary. Now we have to tell MySQL exactly what columns we're supposed to be joining on. I'm going to hit enter and I'm going to hit tab. Now you don't have to hit tab. It just looks more code-like and it's easier to read. And that's how I've done it for other programming languages as well. So that's how I'm going to show you how to do it. What we need to do is say on. Now this keyword is going to allow us to say we're joining the demographics table to the salary table based on these two columns. So from the demographics table, we're doing the employee underscore ID is equal to, and then in the salary table, it's also the employee ID. Let's do employee, and you spell it right, employee underscore ID. Now, if we try to run this, and let's do this, we're going to get an error. And let's bring this up. It's going to say column employee ID on the end clause is ambiguous. Now, what does it mean ambiguous? That means that it doesn't know what table this employee ID is from. Is it from the employee demographics table? Is it from the employee salary table? We don't know because it's ambiguous. Now, what we can do is we can specify it by saying employee demographics dot employee ID, and then employee salary dot employee ID. Now, if we run this, we're going to get the output that we're looking for. And let's take a look at this real quick. Let me bring this up. So we're pulling everything from the employee demographics, that's right here, all the way through the birth date. Then we're pulling the employee salary table. That's the employee ID all the way, let's scroll over, through the department ID. So we're basically pulling in all of the rows or all of the columns from both tables, but we're not pulling in all of the rows. Remember, an inner join is only going to bring over the rows that have the same values in both columns that we're tying on. So in this employee ID, we're missing number 2. Are we missing any other ones? No, we're only missing number 2. Let's go back up and I'm going to run both of these tables. I'm going to take a look. So let's run this. So you'll notice in the employee salary table, we have a number 2 right here, and that's Ron Swanson. But in the employee demographics table, we don't have that. I believe that Ron Swanson did this so that Leslie Knope would not know when his birth date was because he didn't want to bring that information. I think that makes the most sense, although Ron was not willing to give a comment on that. Now, if we run this again, you'll notice that 2 is not in there. Since 2 is not in the employee demographics table, the employee ID 2 is not going to be populated or brought over into this output from the employee salary table. Now, really quickly, this is honestly giving me some anxiety because this is so incredibly long. Something that I mentioned in the beginner's series is that you can use something called aliasing when using joins, and that's really helpful. This is what I mean. So right here, we have employee demographics. We're going to call this DEM. You can also do as DEM. You can do as SAL. These are just short names for demographics and short name for salary. And we can replace these and say DEM.employee ID and SAL.employee ID. Oh, that looks so much better. Now we're going to run this and it'll be the exact same output, but now we're using these aliases, which just makes it so much easier to read. Now, one last thing that I want to show you while we're just looking at the inner join is selecting the actual columns. Let's say we wanted to select the employee ID and we wanted to select age, and then we wanted to select their occupation. If we try to run this, we're going to get an error And it's going to be almost the exact same error that we got before, which is column employee ID in field list is ambiguous. So in our field list, which is right up here in the select statement, we have this employee ID. It does not know which employee ID to pull from, whether it's the demographics or the salary. So we have to tell it which one to pull from. So let's pull it from the demographics by saying dem.employee ID. Now when we run this, we're able to get information from both tables in our output without having all of the information. And if there are columns that are similar in both tables, we have to denote that by using this alias or the table name. All right, so that is inner joins. Now let's move down here. I'm going to copy this and we're going to come right down here and we're going to look at outer joins next. And let's put that right here. Now for outer joins, we have a left join and we have a right join, or a left outer and a right outer join. A left join is going to take everything from the left table, even if there's no match in the join, and then it will only return the matches from the right table. The exact opposite is true for a right join. Let's see how this actually works. Let's start by changing this to a left join or a left outer join. They're both the same and you can use them similarly. I'm just going to say left join. And we're joining it on the exact same things. And I'm going to take everything because I think that'll be easier to visualize. And I'm going to run this. Now you may notice that this looks exactly the same. And that's for a very good reason. It's because in the left table, which is the employee demographics table, the from statement, that's our left table. And then the join, where we're actually joining on, that's our right table. So this is our right table. So since we're doing a left, it's taking everything from the employee demographics. Now, remember, the employee demographics didn't have Ron Swanson. It had no information. So everything in the right table had a match. Well, let's change this to a right join. And what this is going to do, and I want to make it all cap, make it all the same. What this is going to do is it's going to take everything from the employee salary table, but if there is not a match in the employee demographics, it just will have nulls. Let's go ahead and run this. So now it looks a little bit different. Now we're taking everything from the employee salary. So we're taking Ron Swanson, but if there is not a match, it will still populate that row, but it'll have all nulls in it. Then any of the information that is overlapping or the same, it will bring over. So employee ID is matched to employee ID 1. Then we'll bring all that information over from the left table. And that's essentially what a left and a right join is. With a left table, you're taking everything from the left table and then matches from the right table. If you do a right join, you're taking everything from the right table, but only matches on the left table. And again, it populates it with nulls. Now let's go down and look at our last type of join that we're going to look at. And this is a self join. Now, what is a self join? It is a join where you tie the table to itself. Now, why would you want to do this? Let's take a look at a very serious use case. Let's do select everything, and let's do this from employee underscore salary. And let's run this. Now let's say it's December 1st and the employee and Rex department decided to do a secret Santa. And they wanted to assign, based off of their employee ID, the person who they're going to have as a secret Santa. We can help orchestrate this very easily using MySQL. Well, very easily is subjective, I guess, but let's take a look at how we can do this. So just like any other join, the first thing we're going to do is select everything from employee salary and then say join. And then we're going to say employee salary again. So we're tying it to itself. Now, when we come down here, and let me do this. When we come down here and we say on, we have to specify which table we're pulling from. Are we pulling from the left table, which is like the first table we're pulling from, or are we pulling from when we're joining on the right table? We need to be able to distinguish these two tables because they are the same. So I'm going to say EMP1 and I'm going to say EMP2, just to say this is employee table 1 and employee table 2. So we're going to tie them based off the employee ID because we know those will be the exact same because we're pulling from the same table. So we'll do EMP1 dot employee. And just so you know, if it populates like this, you can hit tab and it'll auto finish that for you. And EMP2 dot employee underscore ID. Now, if we run this, let's do this. The output that we're going to get is literally just a 1-for-1 match. It's all the columns and all the rows because they all match exactly. But now what we're going to do is we're going to assign an employee ID to the next employee ID, and that'll be their Secret Santa. So just keep it really simple. The next highest person with an employee ID, that is their Secret Santa. So let's do an employee ID plus 1 is equal to employee2.employee ID. So we're adding 1 over here, and we're saying that's equal to this employee ID over here. Let's run this. So now you can see Leslie Knope is now going to be assigned to Ron Swanson, who has an ID of 2. Ron Swanson is going to be assigned to Tom Haverford, which I'm sure he's really happy about, and so on and so forth. Now let's bring this down here. And what we're going to do is try to simplify this and simplify this output a little bit, because this is a little bit chaotic down here. So we're going to specify what columns we want in our output. What we're going to want is the employee ID, first name, last name, and then employee ID, first name, last name of the person who they got for Secret Santa. So we're going to start with emp1 dot employee underscore ID, and we can call this, we'll just say as emp underscore Santa. Then we'll do a comma and we'll come down. Now I need to spell employee right. So we have our employee ID, and now we need our first name and last name. Now remember, Leslie Knope is going to be the Secret Santa for Ron Swanson. I don't know if I made that clear, but that's, I guess, how it works. So now we need to do emp1 dot, and we'll do first underscore name, and we'll do as, first underscore name underscore Santa. And we can do a comma. We'll do the exact same thing, except for the last name. So last underscore name as last underscore name Santa. Now, all we have to do is copy all this, bring it down here and change this to 2. We're pulling from the second table. And it'll look just like this. And get rid of this comma. And this is done. Let's run it. And let's bring this up. So we have employee Santa, first name Santa, Leslie, last name Santa, Knope, then employee Santa. And we actually need to change these names. That is one thing we need to do. We'll just change it to employee name, first name, employee, and last name, employee. And now when we run this, we have our Santa, and then we just have the employee who this person is going to be the Santa for. Now, this is kind of a silly way to look at it, but in essence, this is exactly how a self-join works. Now, the very, very, very last thing, I promise you, the last thing that I want to show you is how we can join multiple tables together. So we're going to say joining multiple, let me spell it right, multiple tables together. Now, not just one table together to another table. I'm talking about one table to another table to another table. So let's go all the way back up. We're going to take this right here and bring it all the way down. And what we're now going to do is we're going to tie in this table right here, the Parks Department. Now let's actually look at this table, and let's select everything real quick. And let's run this. Now let's go down here and we're going to say select everything. We'll do this from park underscore departments. And let's run this. Now this is something called a reference table. This is not a table that most likely you'll ever add a bunch of information to. It's there to reference that we have these department names. Tables like the salary table or employee demographics table are going to change pretty often as people get raises or as they get older with their age. Those are going to be updated fairly often, whereas this Parks Department table is just there for reference. Now, if we look down here in the columns, we have a department ID, then we have a department name. So we have the ID and the name of that ID. If we run our join and we scroll all the way to the right, you'll notice we have a DEPT ID. This stands for Department ID. That's in the salary table. So what we want to do is join this department ID to the department ID from the Parks and Rec. So what we can do is we're going to say inner join, and now we're going to join. Let's scroll down just a hair. There we go. Now we're going to take this and do it off this. So we're going to call this PD for short. And we're going to say we're joining it on. Now, we cannot join this Parks Department to the employee demographics table. Why is that? Well, the employee demographics table only has employee ID all the way through birth date. there's no common column that we can tie to this parks department. The only table that has a common column is this department ID in the salary table. So what we need to do is actually take sal, so we'll say SAL dot, and then we're going to say DEP, then we'll say department ID is equal to the PD dot, and we need to take the department ID. Now notice these are not the exact same name. They are a little bit different, but they have the same values. One thing I forgot to mention is that in this parks department, there's no repeating. That's why it's a reference. Whereas in the salary, the department ID repeats several times because multiple people are in the same department. So this reference table also usually does not have duplicates. Just one other thing to note. But we have now tied it successfully. Let's try to run this. And if we come down here, go all the way to the right, we now have the department ID, 11111111, and the department ID and department name, Parks and Recreation, Healthcare, Public Works, Finance, Public Works, and Parks and Recreation. So this worked perfectly. So this is how you can tie multiple tables together if you have common columns between them. Even though employee demographics has no column that's related to the Parks Department table, we can still tie them together based through this employee salary, because employee demographics can tie to employee salary, and employee salary can tie to the Parks Department. And that really is the majority of what you need to know in order to use joins well. Hello everybody, in this lesson, we're going to be taking a look at unions in MySQL. A union allows you to combine rows together. Not like columns like we were doing before with joins, where one column is next to the other. A union allows you to combine the rows of data from separate tables, or from the same table, it's up to you. But you do that by taking one select statement and using a union to combine it with another select statement. Let's see how this actually looks. So what we're going to do is right after this select statement, we're going to come here and say union. Then we're going to go right below the union and we're going to do another select statement. So we're going to copy this, place it right here. But instead of the demographics table, just for example, we'll do the salary table. Now, if we look at the demographics table, let's say we want to take age and gender. And let's go and take a look really quickly at the salary table. And let's say we want to take a first name and last name. We'll do first underscore name and last underscore name. Now let's go ahead and run this and see what it looks like. And let's pull this up. So as you can see, we have age and gender. That's from the very first select statement. And that's also the column names. But then we have all of the data for the age and gender. And then below, if we move this over a little bit, we have the last name and first name from the employee salary table. It's just down here. Now, what I just demonstrated is that this doesn't always work for everything. You can't just combine random data together because this is bad data. We shouldn't have age and gender mixed with first name and last name. Really, when you're using this, you need to keep the data the same. So for us, we should take the first, and I'll actually just copy this, the first and last name from the employee demographics as well. And let's run this. And now we have all the names from all of the tables. Now, you may be thinking, where'd all the other data go? Before we had a lot of rows, but now we only have a unique row for each one. Well, by default, this is actually a union distinct. And if you remember, distinct is only going to take unique values. So when we're doing this, union is going to remove all the duplicates. And the first name and last name from salary overlaps a lot with the employee demographics table. So when we ran this, the only one that's actually somewhat unique to one table is that in the employee salary table, we have Ron Swanson, whereas we don't have that in the employee demographics. Now, if we wanted to show all of them without the distinct, there is something called a union all. If we run this, now we're going to get all of the results without removing any of the duplicates. So if we were to scroll down, we're going to have duplicates in here, but we're just showing all of the results from this table and from this table. Now that we know how to actually use a union, let's look at a use case. So let's go right down here and let's copy this. Why not? And let's put it right down here. Now, let's say in the employee demographics, we wanted to take the first name and last name where the age is greater than 50. And let's run this. So there's only one person, but let's label them. Let's add a label. We're going to say comma old. So this person is old. And if we run this, it says first name, last name, and old. And we can even call this as label. And if we run this, the label is old. So Jerry Gergich is the only old person in this demographics table. Now, why are we doing this? Well, the Parks Department is trying to cut their budget a little bit. They want to identify older employees that they can push out, and they also want to identify high-paid employees who they can reduce their pay or push them out to save money. So we just identified someone who's older who we're going to want to try to push out, but let's in the same output find people who are also highly paid. So now we can come down here, we can say union, and let's do this like this. I need to spell this right. All right, union. And let's take this. We're not going to be using this exact same query, but we actually need to pull from the salary table, so the employee salary. So we also want the first name and last name, but let's say where their salary is greater than, let's say 70,000, because that's a lot of money. If you're making more than 70, for sure the Parks Department is going to try to get rid of you. But for the label, we're going to change it to a highly paid employee. Now let's go ahead and run this. So now we have Leslie Knope and Chris Traeger. They're both labeled as highly paid employees. Now, 50 I think is just a little too low. If I'm being completely honest, I think we need to change this, and we should do a union and then add another select statement. Let's bring this down. I think the 50 is too low. Let's change it to 40. And let's add one more thing. Let's say, and the gender is equal to male. And then we'll go down here and say where the gender is equal to female. Because we want to separate this out. So we want to know who's the old man. Oh, that's actually old lady. This is the female one. And for up here where it's male, we'll say old man. So we have 3 different select statements using 2 separate unions. We're selecting the first name and the last name in all of them, keeping the data consistent. And then in our third column, we're labeling it either old man, old lady, or highly paid employee. Let's go ahead and run this. And let's look at our output. Now, you may notice something really quickly, that Chris Traeger and Leslie Knope are an old man and an old lady, and Leslie Knope and Chris Traeger are both highly paid employees. So these people meet multiple criteria. So let's actually order by, and then we'll do first underscore name, comma last underscore name, because we want to order by these to see. So let's run. And now we can easily see that Chris Traeger is both of these. Donna is just an old lady. Jerry is just an old man, and Leslie is both an old lady and a highly paid employee. So now we can send this to whoever we need to send it to make sure that these people get looked at first so that our job is still secure. The job market is tough these days. You got to do what you got to do. So that is how we use union. And let's just take one more look at it. There we go. So this is how we can use unions. It's kind of a real use case. I've done something very similar to this in my real job, but this is just an example of how you can have multiple select statements all combined or combining the rows using a union. Hello everybody, in this lesson, we're going to be taking a look at string functions. Now, string functions are built-in functions within MySQL that will help us use strings and work with strings differently. Now, we're going to look at a ton of different ones. They all have different use cases, but I'll try to walk through some of those as we go along, but we'll look at a lot of different string functions in this lesson. We'll start off with one that's really simple. This one is called length. So if we select, and then we say length, and let's say we put in, and I don't know why it's popping up like that. Let's say we put in something like sky or skyfall or really anything. If we run this, it's going to give us the length of how long this string is. So if I come down here and we say select everything from employee underscore demographics, and let's add a semicolon here. Let's run this one right down. Now, what we can do is we can look at how long each person's name is. What we can do is just take the first name, but then we'll also do the length of the first underscore name. So if we run this, now we get Leslie, Tom, Jerry, Donna, and it gives us the length of their name. If we wanted to, we could even order by this. So we could do order by, and we could just do 2 for now. And we can order by the length from the shortest name all the way to the longest name. Now, one use case that I've used length for in my actual job was when I was working with phone numbers. I wanted to make sure that they were exactly 10 characters long. Otherwise, something went wrong somewhere in the data cleaning process. So I would go and look at the length and I would make sure they're all 10. If any were above 10, I would go and specifically look at those and try to clean those and fix those up. Now let's go on to the next one. And these next ones are pretty simple ones. At least I think they're fairly simple. We're going to look at upper first. And it's doing the same thing as the other one. We'll do upper, and let's say we're going to do sky. If we select upper sky, it's going to give us an all uppercase. Or we can copy this, and we can do lower. So now, let me add semicolons, otherwise it's going to drive me crazy. Let's try this lower now. It's going to do all lower, even if I make it all capital. So if I say all capital sky, it's going to make it all lower. So if we come back up, let's copy this. And instead of doing the length, now we'll do upper. Let's go ahead and select this. So we have Leslie, and then we have the upper first name. So upper, all case Leslie. Now this is actually really good. This is really helpful, especially with standardization, is what I found a great use case for it. Because sometimes it'll be all capital Tom, and sometimes they'll put it in as T, lowercase om. And just making them all uppercase or all lowercase can help correct those really simple standardization issues within a single column. The next one that we're going to look at is trim. Now, there's multiple trims. We have trim, left trim, and right trim. Trim is basically going to take the white space on the front or the end and get rid of it, which is really, really helpful. So what we're going to do is we're going to come right here. We're going to say select, and we'll start off with trim. And let me add a semicolon every time. So then we'll do trim. And for our actual string, we'll do something a little bit odd. We'll do some spaces, and then we'll do sky, and then we'll add some spaces. Now let's run this and add our semicolon. That's going to be the end of me in this lesson, just adding semicolons. Now it fixes it completely. Now what if we don't add sky at all? We'll just keep it like this. Well, you can see that there's spaces before and there's spaces after, but that's what trim does. Trim gets rid of the leading and the trailing white spaces. Now, if we come up here and we just do the left trim, it's only going to remove from the left-hand side. So we're only getting rid of the left-hand side white spaces. This right-hand side, as you can see, is really long. It's still there. And if we do R trim, we go ahead and run this one. It gets rid of the white space on this side, but it doesn't get rid of the left space on this side. Now let's keep going. We have a lot to cover still. We're going to move on to what I think is probably my most favorite string function, if I'm allowed to have a favorite string function, and that's substring. But I'm going to kind of work us into substring a little bit by looking at two smaller functions, which is left and right. So let's select everything, and we'll do that from the employee demographics again. Let's add our semicolon. Now I'm going to run this. Now I want to get the first name, and I'm going to do left of the first underscore name, just like this. Now, when you're using this, there's actually going to be an error. Let's see if I highlight over this, if it'll tell me what the error is. It says the parentheses is not a valid position. They're expecting something else. And basically what they're telling us is that this is not how it should be written. We're looking for a different value. And that different value is actually a number. We're going to do comma, and let's do 4. That's what it was looking for. It didn't want this at the end. It needed this comma 4. And what we're actually specifying is how many characters from the left-hand side do we want to select. So we're selecting the first name and we're going from the left 4 characters. Let's go ahead and run this. And so we have Leslie, Tom, April, all the way down. You can see that there's only 4 characters in each one. So someone like Chris, the S is no longer going to be there because we're only looking at the first 4 characters. Now we can do the exact same thing. And let's actually copy this down here. So we'll go like this. Try to make this a little more professional. And we'll do right. So now we'll do right. If we do the right 4, it's going to go from the right-hand side of the string and go left 4. So we're looking at the far 4 most right characters. Now this can be useful in certain instances, but if I'm being honest, I don't use these that much. For the most part, I'm pretty addicted to using substrings. I love substrings. I think they're fantastic. And let's look at substrings like this. So a substring is going to allow us to do a few different things. Let's do first underscore name. The second thing that we put within this function is the position that we want to start at. So let's say we want to start at the third position, and then we specify how many characters we want to go. So with this, we specified 4, but let's just do 2. So now we're going to the third position, and we're going over to the right 2 characters. Let's go ahead and run this. So with Leslie, we get SL. So we go 1, 2, and 3. We start at the third position, and then we take 2 characters, the S and the L. I have found this one to be extremely useful. Let's take this for example. Let's do comma. Let's do birth underscore date, and let's run this. I'm keeping everything in here, although it might be a bit much. But let's say we have this birth date, and this middle column is the month. And we're running some, query. We want to find the month that everyone is born. So we can do that very easily using substring. And we wouldn't have been able to do this very easily using left or right. So now we're going to take this birth date and we're going to use this substring. And we want to select these middle characters. So what we need to do, since it's all standardized, we do 1, 2, 3, 4, 5, 6. We start at position 6. And we want to select 1 and 2. Let's go ahead and run this. And now we've pulled out all of the months. So we can say as birth underscore month. And now we could save that, put it into a temp table, add it as a new column in our table, whatever we want to do. But now we have this information that we desperately wanted to know. So that is left, right, and substring. Again, substring it's fantastic. Now let's keep going. The next thing that we're going to take a look at is replace. Now replace will replace specific characters with a different character that you want. So let's actually copy all this right here because I don't want to keep writing this out. And we'll say select everything. Now what we're going to do is we're going to take the first underscore name, and then we're going to say replace, and then we'll also do the first underscore name. But we can specify what we want to replace and then what we want to replace it with. So we have 2 more parameters that we need to put in this function. So let's say A, and let's replace it with a Z. Let's just see what that does. Let's go ahead and run this. And so now when we see the letter A, and we are specifying a lowercase a, like Mark, that is replaced with a Z. So that's really all replace does. It specifies what you want to replace and then what you're going to replace it with. Now let's take a look at the next one, and we're going to take a look at a function called locate. So if I say select, and let's do locate, I'm going to give it a string. I'll say Alexander, that's my name, and I'm going to specify what I'm looking for. So let's close this parentheses. The string that we're actually looking for comes first. So what we're going to do is I'm looking for the letter X in my name. So we'll do X and Alexander. Let's go ahead and run this. And it tells us that it is in position 4. So we have 1, 2, 3, and 4. That's where our position is. That's where it locates that sequence that we're looking for. Now, if we pull this down here, place this right here, and we'll change this locate. Now, let's say we're still looking at the first name, but we want to locate people that have an A-N, like this, in their name. Let's go ahead and run this. And we get zeros for everybody except for Anne and Andy. So this might be something where we put it into a CTE or a temp table. And then we can filter down based off of these results to where it only equals 1. Now the last one that we're going to take a look at, and let's go right here. We're going to do first name, last underscore name. Now this one is super useful because what we can do is have a concatenation of multiple columns. So let's go down right here. So we have first name and last name, but if we come down and we say concat, we can then combine these columns into one single column. So we'll do concat, and we'll do first underscore name, and then comma, last underscore name. And if we run this, it's going to be Leslie and Nope combined into Leslie Nope. Now this doesn't look perfect, right? We don't want it to look like that. All we have to do is come in here, and we could do a little space. So we'll add a space in there. And if we run that, now we have Leslie and Nope, and we could call this as full underscore name. And this is something that I've done a million times in my real job, where there's multiple columns. We want to create one column out of it, or take two columns and create one column. Happens all the time. So this concat is really, really helpful to combine those columns really quickly. Hello, everybody. In this lesson, we're going to be taking a look at case statements in MySQL. A case statement allows you to add logic in your select statement, sort of like an if-else statement in almost all other programming languages, or even things like Excel. Let's see how this actually works. So let's bring this down and let's take this employee demographics table and let's take the first name and let's take the last name and let's add a case statement. How we need to do this is we have to say case. So that's going to signify that we're starting a case statement. And then I'm going to go over here and say tab. So this is where our logic comes into play. So I'm going to say when the age, let's say, is less than or equal to 30, then. So I'm saying if the age is less than or equal to 30, then what's going to happen? We'll just keep it really simple for now. We'll just say that this person is young. And then if we want to end the case statement, we'll come down here and say end. So this is a complete case statement. Let's go ahead and run it. And let's take a look at the output. So we have the first name, we have the last name, and then we have this case statement right here. And if their age is less than or equal to 30, they're young. Now let's actually add the age right here, just so we can visually see that as well. So we have the age. So this person is the only person who's under or equal to the age of 30. That's April. So she has a label of young. The great thing about case statements is you can add multiple when statements. So we can come down here and say when, and then we could do something like when age, and maybe we'll say between. So I don't know if in previous lessons we've looked at between, but between just says between this number and this number. So we'll say between 31 and 50. If they're between 31 and 50, well, good night. That person is old. So we're going to have it just like this. We're going to run it. And now we have a lot of people who are old. These are all people between the ages of 31 and 50, but we still have more people outside of the age of 50 or older than 50. So we could do when the age, and now we can say greater than or equal to 50. And we're going to say then, and then we're going to say on death's door. Because good night. If you're over 50, my parents are going to love me for this one. So let's go ahead and run this. And then if we look at this, we have on death's door right there. Now this is huge. This is massive. So let's actually name this, and we'll just say as at the end of end. So right after end, we'll say as age bracket. And let's run this. And this looks a lot better. So now we have this age bracket, just signifying kind of where people are at, and most people are quite old. Poor Jerry, can't catch a break, that guy. Now let's go down and let's take a look at a different table. So let's select everything. We'll do from employee underscore salary. Now that we have our employee salary table, here is the scenario that we are given. The Pawnee Council sent out a memo of their bonus and pay increase for end of year. And we need to follow it and determine people's end of year salary or the salary going into the new year. And if they got a bonus, how much was it? So the first thing we need to do is we need to get the pay increase and bonus. And their pay increases look like this. So if they made less than 50,000, then that equals a 5% raise, very generous. And if they made greater than 50,000, that equals a 7% raise. Very, very generous. Lastly, if they work in the finance department, that equals a 10% bonus, just cash that goes into their bank account. Very, very generous, but only the finance department gets it. So these are the guidelines that the Pawnee Council sent out, and it is our job to determine and figure out those pay increases as well as the bonuses. So let's come right down here. We're going to have our salary employee. I actually want to be able to see these. Let me pull this up just a touch. There we go. So we want to be able to write this out. So first thing we should do is just select the columns that we need. First name, last name, probably salary as well. And now what we can do is determine this first one, which is if they make less than 50,000, they get a 5% raise. So let's say case, and I'll also add end in here. And we're going to say when their salary is less than 50,000, what's going to happen? Then we say then salary. So we're taking their initial salary and we're saying plus, then we're going to do salary times 0.05. And if we run this, it should work. Let's pull this up really quickly. So April Ludgate, she made under 50,000. So she got a raise and her new salary is 26,250. We can actually call that, we'll say as pay underscore, actually let's do new underscore salary because that's their new salary. And let's run this. So the new salary is 26,250. Andy Dwyer is now making 21,000. Now this calculation, you can do it different ways. We can do it exactly like this, or we could just do times 1.05. Should be the exact same thing, just however you would like to write it out. It's just, adding it or multiplying it by this. So let's take this. And now we're going to say when it is greater than 50,000, so let's say greater than 50,000, they get a 1.07. So this is the 7% increase. This is a 5% increase. This is a 7% increase. And let's run this. And let's put this up here. So now if they made greater, so 50,000, that's 75,000, they got a 7% increase. Now, unfortunately, we did not make the rules, the Pawnee Council did, and the people who made exactly 50,000, unfortunately, were not part of those brackets, and that just wasn't up to us. We couldn't control that. So unfortunately, Tom Haverford and Jerry Gergich just didn't get raises this year. And that's not our fault, okay? That's not our fault. Now, the next thing that we need to do is determine the bonuses. Now, let's come right back up here really quickly, and let's just copy this, because what we need to determine is how we know that somebody is in the finance department. Because if they're in the finance department, that means they get a 10% bonus. That's really important. Now, it's not in the employee demographics. Don't have anything about the department. But if we look in the salary and we run this, we do have the department ID. Now, let's open up and let's pull this up right here. We'll look at the Parks Department. And in the Parks Department, here we go. The finance is department ID of 6. So if we're looking at the salary, there's only one person who's in department ID equal to 6. So what we can do is another case statement. We can say, comma, we'll do case and end, and we'll do another one. We're going to say when DEP-TID, so when the department ID is equal to 6, then we're going to give them a bonus. So we're going to say salary times 0.10, and we'll call this as bonus. Let's go ahead and run this. And let's pull it up. So he gets a $7,000 bonus this year. That's Ben Wyatt, because he was part of the finance department that just did an exceptional job this year, apparently, according to the Pawnee Council. So that is how case statements work. They're really powerful, really useful. I honestly use them quite often. And they're just a way to really add some logic and some, labeling or even do calculations like we did right here with the salary. Hello, everybody. In this lesson, we're going to be taking a look at subqueries in MySQL. Now, subquery is basically just a query within another query. We can do this in a few different ways, and I'm going to try to show you a lot of the different variations within this lesson. The first way that we're going to use a subquery is in the where clause. Then we'll take a look at the select and the from clause also. Let's take this demographics table that we have down here. What if we only wanted to select the employees who worked in the actual Parks and Rec department? Well, we could do that if we had a few joins. We have this salary table, and one actually represents that they work for the Parks and Rec. If we come over here and we open this up, we can see that Parks and Rec is the department ID of 1. So we do have that option. We could just join these two tables together, but sometimes we don't want to do that, and we'll use a subquery. Let's see how it works in the where clause. So let's go ahead and get rid of this. So what we're going to do is we're going to say select everything from employee demographics where And now we want to pull, because this is the salary table, we want to pull employee IDs where the department ID is equal to 1. But remember, we're querying off of this table. So let's actually pull this up. This is what we're working with. So we want to say where the employee underscore ID, that's referencing this column in the demographics table, is in, what we're going to do is we're going to do a parentheses here, and we can even come down and put a parentheses down here. So what we're going to do now is write our query, which is our subquery, and this is our outer query. So now we're going to write an entirely other query within this. So we'll say select, and now we're going to say employee underscore ID, and let's just bring this over. I usually have it something like this, and I'm going to try to bring this down a little bit. So select everything, and then we'll do from, and then instead of employee demographics, we'll do employee salary. And let's just format this a little better. So select the employee ID from employee salary. And remember, we wanted to do where the department ID is equal to 1. Now let's bring this back up. And this is what the query is going to look like. Now, just by itself, let's run this subquery or this inner query. When we run this, it's going to create this list of just employee IDs where the department ID is equal to 1. So when we say where the employee ID from the employee demographics table is in, it's going to try to match those employee IDs to this list of employee IDs. So just remember 1, 2, 3, 4, 5, 6, and 12. Let's go ahead and run this entire query. Now we have 1, 3, 4, 5, 6, 12. If you remember from previous lessons, the 2 is Ron Swanson, and he's only in the salary table. So since we're doing just the employee demographics table, he's not in here. So what we're doing is we're selecting everything from the employee demographics where the employee ID in this table matches or is in the select employee ID from the salary table where the department ID is equal to 1. In essence, this is what a subquery is. It's a query within a query. Now, what would happen if we have the employee ID, but we also wanted to say the department ID, because we just wanted to view this. Let's go ahead and try to run this. We are going to get no output, and we're going to get an error that says operand should contain 1 column. The operand referring to this entire thing right here, because this is an operator. So this is our operand, and we're returning 2 columns in here, which is saying we cannot do. We have to only have 1. So now if we run this, it works perfectly well. And let's bring that down. Now we can also use the subquery in a select statement. So let's take a look at that next. Let's go down here and let's say we want to do select everything from employee underscore salary. And let me spell that right. Let's say we want to look at all the salaries just like how we have it now, but in a column next to it, we also want to compare it to the average salary for everyone. So we'll be able to see, whether somebody's salary is above average or below average. So what we would try to do potentially is do something like first underscore name, salary, and average salary. And we try to run this. And of course, we're going to get an error. It's going to basically tell us that we need to group by if we're doing this. So let's go back down and let's actually add that group by. And we'll say group by first name and salary. And we'll look at this output. And this is not looking good at all. It's just looking at the average salary for each unique row, which is Leslie, 75,000. So the average is 75,000. This is not what we're looking for. This is not what we want. Here's what we really do want. We want to just take the average salary of this entire column, regardless of group by or anything else. So let's get rid of this and let's see how we can do that. So let's come right down here. We're going to say select the average salary. And then we're going to say from, out of parentheses, because this is our subquery, from the employee salary table. Just like that. Now, if we run this, we should get the exact output we're looking for. So the average salary is $57,250. And we have our salary right here. So we can compare really quickly, just like that. Now we can also use a subquery in the from statement. So let's go down here and let's say select everything from employee underscore demographics. Let's have it autocomplete for me. So we have the employee demographics table. Now let's create a group by based off the gender column and add some aggregated functions. And I'm going to show you how you can use this as a subquery. Let's go up here, say gender, and then we'll just go ahead and add our group by. So we'll say group by gender as well. Now let's add a few things. We'll do average, we'll do average age, and then we can do, let's just do all of them based off the age. We'll just do age, min of age, and count of age. Ooh, when I try to write fast, it doesn't always go right. So we have this, let's run this. And this is what our output is going to look like. Now, what if we wanted to get the average of the oldest age or the average of the smallest ages, or, see what the average count is for males and females? Well, we can't do that given this table, but let's do something right here. Select everything, and then we're going to say from, and in our from statement, we're going to have a parentheses. We're going to paste our select statement and then close the parentheses. So we're going to select everything from this output that is right down here. So if we run just this, we're going to get an error, and forgot this was going to happen, but every derived table must have its own alias. So you have to name a table. I forgot it does that. All we have to do to fix this is just name it. So we'll say as, and we'll say aggregated table. We'll just call it aggregated table. So let's run this, and we get the exact same output. But here's the neat thing is we can now select, we can do gender, and these are actually the column names now. So I can do the average of this column right here, but I can't do it just like this because it's going to give us an error. And I'll show you why in just a second. It says unknown column age in field list. So what it's saying is we're trying to perform an aggregated function on the aggregation of an age column, but we don't have an age column in our table right here. Let me run this again. We have a column named this exact thing. So what we actually need to do is do this backtick and backtick. This is the actual name of the column. It's not an aggregation anymore. The backtick on my laptop is right above the tab on the far left-hand side, right under the escape. That's where mine is. So these backticks, it's not a quote like this, it's a backtick. So you just need to find that on your keyboard. But now if we run this, it looks like we encountered another error. It says in aggregated query without group by. That's right. Now we need a group by. So now we need a group by gender. Sometimes you got to figure this out on the fly, and it should work. There we go. So now we can perform aggregations on this table. Now, this doesn't actually work perfect because we're still grouping by the female male, but let's get rid of this for a second, and we'll get rid of this group by entirely. And if we run this, we're now looking at the averages of this column right here, max age. Now, when you're doing something like this, it's actually really smart to rename these. We'll say as average underscore age. We'll say as max underscore age, and it makes it so much easier. You don't have to do these backticks anymore. And as min underscore age, and so on and so forth. And I would probably format this better and stuff like that. But we don't have to go through everything, right? I'm just kind of giving you an example. But then when we're using this table, these columns are actually named this. So I don't have to do these backticks anymore. I can just take this whole thing. Oops, get rid of that backtick. Now I can just take this column because this is the column name. So let's go ahead and run this, and it's still going to work perfectly. So this one's pretty cool.